we're going to go ahead and demo our electronics lab project. Jonathan's our group leader. Is going to go ahead and introduce kind of like what we did over the course of these past few weeks this semester, and how we divided those tasks for this project. So I think Jonathan will go ahead and start off with the first task that you did.
Morning, Dr. Wolf. I'm Jonathan Ark. I'm the team leader for Project Team 7. I wanted to go ahead and make this video to help show you our project here. The project was inspired by this guitar that I received from my father. That was a project of his that he had never finished, but that I thought he had intended to give to my kids. And so I went ahead and got it working, but was never happy with the volume, which just not very loud. It's all right. Has a little half-watt amplifier in it, but it's not very loud out of the speaker. And so this project gave me the opportunity to work with a team to design a stronger amplifier to eventually go in this guitar that is similar and has similar features. Originally in the guitar it uses an AN7112 half-watt amplifier, but we decided to build this circuit using the AN7111, which is a 1.2 watt amplifier. And here's the finished product. We started by building the basic version presented in the data sheet of the AN7111 that shows an application circuit, and onto which we added several features, starting with those that are in the guitar: the potentiometer, an on switch, and a power indicating LED. But we went a little further and added a reverse polarity protecting diode and an auxiliary input and a overdrive effects. So to demonstrate the final product, go ahead and plug in the guitar, which will send the signal over to the amplifier.
Here goes zoom into the microphone.
Turn. Here's the on button, which turns on that. We can go ahead and we close it. Got the speaker built into this box. And so here's the sound, not distorted at about, which, as you can tell, is quite a bit louder than the original. I can turn that off and then turn the original back on. You can hear that's the original. Turn that off. Turn this one back on. And now you can hear it much louder. And then if I turn on the distortion, we get a nice punchy distortion effect on the same amplifier. Now, some of the other features that we added to this was the auxiliary input and the headphones jack. So let me demonstrate do you want to go ahead and do?
Yeah, so I was tasked with doing the headphone jack, and we went ahead and implemented this UXL PCB mount onto the PCB. And this allows us to go ahead and input another source of volume or another source of input to go ahead and you can play along with the music that you go ahead and want to play with.
So
you
can plug in the headphones
yeah.
first to demonstrate that the circuit speaker cuts off.
Yeah. So now it's playing volume through the headphones, and we made sure to cut off the volume from the guitar and the speaker as well. I'm sorry. Yes.
And unplug. Then show the other feature, which would someone somebody have someone they can play. Count on the phone to do it.
Shoot.
We could cut it right here, and then y'all can add the next clip, right?
That's all.
Yeah.
Why don't we do that towards the end? Then
Okay.
We can go ahead and keep rolling.
Yeah.
And we'll. Who would like to go first on discussing their individual contributions?
Want to go?
Yeah, I can do it.
Yeah.
Mr. Bryan right here. Go ahead, Mr. Bryan.
Yeah, so I was tasked with doing the potentiometer. So originally we had discussed to do a 1 mega ohm potentiometer because even when the guitar was at its lowest volume, you would still hear some feedback from it. But we wanted to replicate what the guitar had from the original, which was at a 500 kilo ohm potentiometer. So we ended up going with the 500 kilo ohm that we eventually put into the circuit. And then found out that one of the unused terminals connected that to the ground kind of resolved our problem that we had with the feedback. Yep, so that was the part I had to do. Just a potentiometer volume adjusting knob here.
All right. 1 in 4 zeros. Hello, I'm Jordan Din, and I was tasked with the reverse polarity protection diode, and you can see it in here. It's right there. So the point of the reverse polarity protection is to kind of save all the components from like a reverse voltage. Like for example, the easiest way to do that, not easiest way I guess, like this most simple way to do that is to accidentally plug in the battery terminals or like backwards I guess. Like if you put the negative where the positive is supposed to be, like without the diode, like you could fry out all the parts and you could like, I mean in higher scale cases you could start a fire or it could be like an electrical shock. And there's many ways to do that. Like you can use a regular conventional diode, a Zener diode, or a Schottky diode. And in our case, we just found it easiest to use the 1N4001 diode because it's just the one in our lab kits and it does the job like that we need it to. And that's about it.
Yeah. Okay, yeah. So I was, my name is Jorge Arredondo, and I was tasked with the headphone jack. So if you want to scoot in here, we were able to use a PCB mount 3.5 millimeter 5-pin socket headphone stereo jack video connector. So what that allows us to, we go ahead and put the pins into the breadboard here, and it allows us to cut off the speaker input, or not the speaker, here you can point here at the speaker, so we can make sure that the audio is going towards the headphones when we plug it in, and take it off to cut off the audio as well.
Right. So my task was to build to implement the on and off switch. So you can see it right here, and we use E-switch TL2230 to do this and to allow the flow of electricity when we need it to. So we also found out that when you turn on the amplifier, you can hear always like a popping sound, right? So what we find out right here, if you can show it, is that the amplifier, the AN711, it has already like a ripple filter, which is sufficient to prevent the popping noise.
My individual task in this was to find the placement of the power indicating LED, which is not a totally trivial part because it can indicate that there's a problem in the circuit, primarily that your battery is going dead. The major part to remember that I needed to add was the current limiting resistor, which through some testing and iterative design techniques, I decided worked best at 10 kilo ohms resistance, which limited the current enough while still leaving the light illuminated enough to see. And this saves some power while also protecting the LED. Some of the other components I had added along the way, since we had some of these extra parts, including other jacks and switches, I found a way to use one of the extra jacks as an auxiliary input for playing music through it at the same time, as well as the switch to activate distortion on it. That works by when it is not pressed down, will push the signal sound through some resistance to limit the max power or max current to below the threshold for distortion, and then when the switch is pressed, it sends the signal directly into the op amp, which causes some distortion effect. So everybody,
we're gonna go ahead and demonstrate how putting in we're gonna go ahead and see it. The 3.5 millimeter auxiliary allows us to output the volume of the computer for the music to play along with it. Right.
thing. Doesn't want it blasting us right away.
Oh,
Good.
yeah.
Let's see.
One of the switches might be off.
No, that switch is on. So.
Oh, you got the. Sure you're not?
Wait, this one is plugged into nothing. Oh, is it? Oh, fuck my bad.
Oh, that should be good.
Yeah, it should be good. So.
There we go.
There we go.
It was just a computer, computer's fault. So now we can hear the music playing, and we can go ahead and control the volume as well. You can see that it goes significantly lower and also increases the volume as well. And then Jonathan will also demonstrate how we can play the guitar while also playing music as well. Oh. So then, that pretty much concludes our demonstration. All right.
Everyone want to come in?
Yeah.
So thank you to Dr. Wolf.
All right. Thank you, Dr. Wolf, for your time to watch this video. We hope you're doing well.
Yeah.
Yeah. That concludes our demonstration.